Hello guys, we're gonna provide solution to this given problem. Given that x to the power of x squared minus 2x plus 1 equals 2x plus 1, then we find the values of x. Okay, solution. So what will you call this kind of equation? Is it quadratic equation or exponential equation? So we're gonna call this to be exponential equation because the unknown variable is at the power here, even though we have it as the base here, which is x to the power of x squared minus 2x plus 1. So the power x squared minus 2x plus 1 makes that to be exponential equation. Okay, and then so what are we going to do here? Now, as this kind of question, you need to be very careful before you solve it. Analyze the question first and look at the best way to get the results. So that's the best way to go about this. You don't just jump to the solution and just start solving. Okay, it is not done like that. So you need to analyze, study the questions, and look at the similarities. Then from there, the best approach comes in. Okay. Now looking at this, you have x squared minus 2x plus 1 here. I have something like minus 2x plus 1 and I have 2x plus 1 here. Something is similar there, just that here is minus 2x and here you have plus 2x. Okay, yeah, what if you break this down? I mean, what you have at the left hand side, we can break that down to be x squared. Okay, so times x to the power of minus 2x plus 1. All right, so equals what? 2x plus 1. Okay, so now what are we going to do from here? Now let's multiply both sides by x to the power of 2x plus 1. Okay, multiply both sides by x to the power of what? 2x plus 1. Okay, if we do that, we're gonna have x squared times x to the power of minus 2x plus 1 multiplied by x to the power of 2x plus 1, then equals x to the power of 2x plus 1 times 2x plus 1. 2x plus 1. What's this? 2x plus 1. Okay, so now using the law of indices for this one, this and this, we're gonna have x squared times x to the power of minus 2x plus 1 then plus 2x plus 1. I'm sure we know that from the law of indices, when you have x raised to the power of a times x to the power of b, this can be written as a plus b, x to the power of a plus b. Okay, then you have x to the power of 2x plus 1 in bracket of 2x plus 1. Okay, and of course this is plus 2 and this is plus 2x. Okay, minus 2x plus 2x, so that would cancel out. So we now left with x to the power of x squared times x raised to the power of 1 plus 1 here is 2, then x to the power of x 2x plus 1 and 2x plus 1. You can see something here looks similar. Okay, if you look at the left hand side, the power of x here is x squared and that's what you have here. So at the right hand side, the power of x here is 2x plus 1, that's what you have here as well. Okay, this looks like we're gonna make use of Lambert W function. Okay, and for you to see that clearly, let me just assume let x squared be a and let 2x plus 1 be b. Okay, if you assume this, that means left hand side, that would be x to the power of a dot a, and that of right hand side, that would be x to the power of b dot b, and this can be written as ax to the power of a and this is bx to the power of b. Can you see that now? So this looks like Lambert W function. So if you are just coming across, or if this is the first time you're gonna hear about Lambert W function, you can watch some of my videos on that, so that will give you good insight about Lambert W function. Okay, again, so what we're gonna do here to make that, we can make use of, for Lambert W function, we have, the rule is w of phi exponential phi. So this will give you this. Okay, so yes, we can still apply it here even though we don't have exponential here. We can still apply it here. So by the time you apply it here, ax raised to the power of a, then w of bx raised to the power of b. This will give us what? A equals b. Do you understand? Okay, you know what? Let me just quickly prove this, how we can actually apply it here, because I know some students will be like, oh wow, why do we have to change this rule now? The rule is exponential, so but now we have x, why are we changing the rule? This will actually give you the same result, okay? But the thing is that from here again, ax raised to the power of a, bx raised to the power of b, I can rewrite a here to be exponential x to the power of a. I'm sure you know that. And b, x to the power of b here can be written as exponential in x to the power of b. And of course, this is a exponential a ln x, and this is b exponential b ln x. Okay, so you can see we have a ln x here, but we only have a here. We have b ln x here, we only have b here. For you to have same thing now, you multiply both sides by ln x. So, and that would give you a ln x exponential a ln x, then b ln x exponential b ln x. So you've seen your exponential that you are looking for. So I believe you can now apply Lambert W function. So when you do that, when you apply Lambert W function, then this is a ln x and b ln x. So what happens here? Ln x, you cancel ln x. So I have this. Okay, so but next time we don't need to do this ceremony, okay, before you get this. So this follows Lambert W function rule as well. Okay, now going back to this. Now from here we assume a to be x squared and b to be 2x plus 1. So let's replace that. This is x squared, then 2x plus 1. Okay, so let's rewrite this in terms of quadratic equation. That will be x squared minus 2x plus 1 equals 0. Okay, then when you solve this, you can use quadratic formula. You can use what's it called, completing the square method. And also, but when you solve this, you know, you're gonna have, if I'm going to use quadratic formula, which is minus b plus or minus, you know that now. So 2 plus or minus root 2 squared minus 4 times 1 times 1. Okay, and here you have what? You have 2 times 1. This is supposed to be minus 1, sorry. So you have minus 1 here. Okay, so x squared, x equals 2 plus or minus 4 times minus 1, that's plus 4, that's going to give you what? 8. Then over 2. So x equals 2 plus or minus square root of 8 is 2 root 2, then over 2. And you have x equals, you can factorize 2 out here, then you have 1 plus or minus root 2 divided by 2. And from here, these two will take care of this. So eventually have 1 plus or minus root 2. And these are the possible values you can get for this. So that is x equals 1 plus root 2 or x equals 1 minus root 2. So x equals 1 plus root 2. I'm sure this will give us positive results. And that would be something like 2.414, yes, and this will give us negative, but I don't know. So these are the possible values we have here. The second value here will give us negative, but can we have negative value for the x here? Okay, let's check that on Desmond's graph. Okay, so the first one here, this line is the equation of for the linear, which is 2x plus 1, and this is for the exponential. You can see the result we have here, 2.142, and we only have one solution to this equation, one value for x. So what happened to the second value? Why we don't have second? Why do we have only 1 point here? You can drop that at the